Hi, and welcome to the first video in a series of videos to better understand certain parts of physics and chemistry. And today we're going to look at the atom and the atomic structure. Well, before we begin, we need to understand what an atom is. And the best way to do so is to figure out how we came to coining this term atom and why we did so. Well, if you're an ancient Greek person sitting in your room, really bored, and you want to be a scientist, what you do is you observe everything you see around you. So you see a scale, you see a pen, you see another pen, and well, you think, okay, how can I group these together? So you can see that this one occupies space, this one also occupies space, and this also occupies space. And they all have certain weights. This scale is slightly heavier, although it looks quite light, compared to these pens. And then they went on to coin the term matter for anything that occupies space and has mass. Sort of like categorizing things, like grouping Persian cats and Siamese cats and saying, oh, they're all cats. So in the same way, all these objects that I have around me, including this piece of paper, it occupies space and has mass, and therefore we decide to call it matter. Now, in order to understand the properties of matter, we need to understand what it's made up of. So then came the next phase, where they coined the term molecule as a constituent of matter. So matter is made up of various different types of molecules. So this pen will have a certain type of molecules making it up. This pen will use a different set of molecules, different number, different organization. They may be located in different places. But basically the point is that if we understand the molecules, then we understand matter. Now, what is a molecule? So a molecule is essentially a particle, which we will look at further later on. But for now, the important thing to understand is that it's an object which has physical and chemical properties. That's the definition of a particle, by the way, an object that we can describe physical and chemical properties to. So a molecule is essentially a particle, and a bunch of these particles can make up matter. Then they decided to break down molecules further and came to an atom. Now, an easy way to understand this would be to think about a brick. So you have one brick. On its own, it doesn't do much. But you take a bunch of them, and suddenly you can make a wall, or a house, for example. And then let's say you put the bricks a different way. You can make a restaurant. Again, just using bricks. And of course, tables and chairs, but get the idea. And similarly, you can make a shop and even an airport. The point is that using a specific type of constituent molecules, like bricks, we can make up different types of larger objects: walls, houses, restaurants, shops, and airports. And then, if we go down one level lower, if we think about sand and clay that goes into making the bricks, the same sand and clay can also be used to make concrete if you mix it with cement, and all of these stuff can be used to make different things. Well, house, restaurant, airport. So we have essentially broken down matter into molecules, broken down molecules into atoms, which are again particles, so objects with physical and chemical properties. And then we're gonna look at what this atom is and try and understand, why did we stop here? Why didn't we decide to break down atoms? Well, we did decide to break down atoms further, but why is it more relevant to study it at this level, at this hierarchy, rather than going down to even smaller and smaller particles? Well, if you think about it, An atom is made, atom looks something like this, right? You have a dense central region, which is called the nucleus, and the majority of the region in an atom is just empty space. So for comparison, a nucleus makes up about 100,000th of the volume of the total atom, which is really small, like a football in a football pitch. Now this empty space has a few dots. I'm going to use a few dots, randomly spread out, well distributed, and these dots are again a different type of particle called electrons. So far we're just naming them. We're naming what some people saw or discovered, and electrons are again a particle. So an object with physical and chemical properties. Now the nucleus, again, we have used the nucleus to define this region, has two types of particles. The names, again, protons and neutrons. Again, they're just particles. Great. Now the question is, why did we stop here? Why didn't we go down further? Well, to answer that, we need to understand what we're trying to achieve is something to explain everything around us. And in order to explain everything around us, we need to understand the physical plus chemical properties. Now, if you had to tell the difference between a diamond, I'm going to draw a diamond like that, and graphite, let's say you knew what it looked like, someone would come up with something like this, for example. Now, the interesting thing is they're all made up of an object, which I'm calling a C for now. But if you look at the shape, this one has a shape of something like that, whereas this one has a flat shape like that. So essentially, in order to differentiate the two, diamond and graphite, even though they're made of the same constituent particles, they are arranged differently. So you need to worry about how the molecules are arranged if you want to think about matter, where they're located, what type they are. But if you come down to the atom, we don't need to worry about any of that. The only thing that matters is number of electrons, protons, and neutrons, at least for all practical purposes. So we just need to know how many there are. We don't need to know where the electron is, where the proton is, where the neutron is, what it's doing, how it's arranged. We don't need to worry about any of that. We just need to know how many there are. And that's why we decided, okay, we're gonna go an atom, break it down further into neutrons, electrons, and protons, and stop there. We won't go on breaking it down further, at least for utility purposes. Obviously, scientists did break down these particles further to look at what they're made of, more subatomic particles, such as quarks, for example. But for most practical purposes, you just need to know this.